A 15 mm diameter high-speed steel drill is used at a cutting speed of 20 meter per minute and a feed rate of 0.2 mm per second. Under these conditions, the drill life is 100 minutes. The drilling length of each hole is 45 mm and the time taken for idle motion is 20 seconds. And the tool changing time is 300 seconds. The number of holes produced using one drill is. Here, first we will have to find out the time taken to drill one hole. Time to drill one hole. So here the length of each hole is 45 mm and the feed rate is 0.2 mm per second. So that here 45 by 0.2 gives the time taken to drill one hole. So which is equal to in terms of minutes we can write it as 3.75 minutes. So here 3.75 minutes time taken to drill one hole, so that the number of holes produced using one drill is equal to drill life. Here drill life is given by 100 minutes by the time taken to each hole, that is nearly equal to 26.67, so that it is nearly equal to 26. So 26 holes can be produced by one drill. A structure consisting of two equal bars as shown in the figure, each 4.5 meter long and with hinged ends, is subjected to the action of a vertical load P. Determine necessary cross-sectional area of the bars when P is equal to 2.5 kN and allowable stress is 250 megapascal. So here in the given diagram, there are two bars of equal length are subjected to a vertical load of P at this point. Let us say this is A, B and C. So here a vertical load acting at the point C, and these two are of equal length, so that here the angle between the second bar and the horizontal line also 30 degrees, and here the angle between these two bars is 120 degrees. Now from the free body diagram, let us say this is T1 and this is T2 and this is P, and this is of 120 degrees, and here it is 120 and here it is 120. So from the sine rule we can write it down, T1 by sine theta, that is sine 120, is equal T2 by sine theta, that is sine 120, is equal P by sine 120. So that here T1 is equal, T2 is equal P. So here we will have to find out the cross-sectional area of the bar when P is equal to 2.5 kN and allowable stress is 250 megapascal. Here T is a tensile force, so that the tensile stress induced in the member is equal to force by area. So that here either T1 or T2 by area is nothing but the stress induced in the member, let us say sigma. So here T1 is equal to 2.5 kilonewton or 2500 Newton, and here we will have to find out the cross sectional area, and sigma is equal to 250 megapascal is equal to cross sectional area of the member, and is equal to A is equal to 10 mm square. So in the option, the right option is D. D is the right option. Determine the change in volume of the steel block shown in the figure when it is subjected to hydrostatic pressure of 180 megapascal. Take Young's modulus is equal to 200 gigapascal and Poisson's ratio is equal to 0.29. So this is the given member. It is a rectangular cube of dimensions 80 mm length, 60 mm width, 40 mm depth. So here the member is subjected to hydrostatic pressure of 180 megapascal. That means it is subjected to a compressive stress of 180 megapascal from all the sides, from x direction, from y direction, from z direction. So in this case we will have to find out the modulus of compressibility, that is also called bulk modulus, and is given by delta P by delta V by V of minus sign. Since here delta P is a compressive stress, so that the change in volume obviously negative, or it is it is the member is compressed further, so that here the change in volume or the with respect to volume is given by minus delta P by K, where this is called generally dilatation. So here we will have to find out the change in volume, that is delta V is equal to minus delta P by K into V, where V is the volume of the member and K is the bulk modulus or modulus compressed, delta V is the change in pressure. So here it is subject to hydrostatic pressure of 180 megapascal and volume also known value, that is V is equal to 180 into 60 into 40. So it is given, it is equal to 192 into 10 cube mm cube. So this is the volume of the member, and change in pressure or the pressure acting on the member is 180 megapascal, and we will have to find out the modulus of compressible bulk modulus. K is equal, we will have to find out. So but here the other known values are Young's modulus and Poisson's ratio, but we know that the relation between the Young's modulus and bulk modulus, that is given by E is equal to 3K into 1 minus 2 mu, where mu is the Poisson's ratio and K is the bulk modulus and E is the Young's modulus. And here Young's modulus and Poisson's ratio values are known values. So by using these two values you can find out the K. So now substitute these two values. Now we can get here K is equal to 158.7 gigapascal. Now substitute all these values in change in volume. So here delta V is given by 180 megapascal and K is 158.7 and here V is 192 into 10 cube, and here it is gigapascal. Now convert it into megapascal. So it gives a value of 218 mm cube, and it is negative because it is compressed. So that in the option, the right option is D. D is the right answer.